Alright, so I'm just going to run through the first tutorial right now, and then I'm also going to do the second one right after, just to explain my process as I go along. But so the first question is, solve for x, the equation absolute value 5x minus 2 equals 7. So when we're thinking about solving an absolute value, how are we going to go about this? So if we imagine the graph of an absolute value, we can kind of imagine it as like the negative case and the positive case being split up according to their shift. Right, so what this means is if we have the absolute value of x, what we're really saying is positive x, that's going to be for x is greater than or equal to 0, and negative x is going to be for x is less than 0. Right, so if we have some sort of shift, which here is 2 to the right, that means that we're just going to have that the solution for this, or the origin point, is just going to be 2 over 5. Right. So if we want to solve for the absolute value of something equal to c, well, what that really tells us is then that if we have the positive case here and the negative case here, that we can just split that up according to the sign. So that gives us ax minus b equals c, or ax minus b equals negative c. So in the case for absolute value 5x minus 2 equals 7, that's just going to give us 5x minus 2 equals 7, or 5x minus 2 equals negative 7. So if we want to go about solving this, right, the first thing we want to do is we have negative 2. We can just add 2 to both sides to get rid of that, because we want to solve for x. Then we're left with some constant on the right side for both cases. We see that we have a 5 attached to the x, so all we have to do there is just divide by 5. And I did draw out the graph of what this would look like. Right, so you can imagine that the origin point here, well, that's just going to be 2 over 5. This marker is not meant for that. Sorry. Okay, so we have 2 over 5 here. The positive case, the negative case, we know it's always going to be above this graph here because we have no shift down or up. And we have y is equal to 7. So we see intersects here and here. Right? In the case where you actually wanted to draw this to be realistic and not a rough graph, we'd have the intersection point here and the actual intersection over here as well. Right? So you can just imagine this is negative 1 and this is negative 5. So what's the second case? Yes, so the second case is dealing with two absolute values. Before I go through the process of that, I'm also just going to explain how this would work. So if we have two absolute values here, what that's really saying is we have the positive and negative of the first one, and then the positive and the negative of the second one. Some people take that to mean that we're going to have 4 solutions, but if we think about the possible cases, so the first case is we have positive and positive. The second case is we have negative and negative. We know that since we're taking the multiples of them, right, then that's just going to mean like a negative number times a negative number, that's going to go to positive, which is equal to positive times positive. So we have case 1 is equal to case 2. Case 3 is that we have the positive and the negative. Case 4 is negative positive. Well, in either case, we can also just, like, say we have positive here, negative here. Well, we can just multiply the negative over to here to make this negative and this positive. But if we have negative here, positive here, then we can just also just do negative here, right? Negative here, positive here. We can just multiply any case, it's interchangeable, right? So case 3 equals case 4. So it means we do only have 2 cases here to deal with. Either 2 positive, 2 negatives, or a positive and negative. Right? So that means we have 2x plus 3 equals 3x minus 8, or 2x plus 3 equals negative 3x minus 8. Right? You can take this to be negative, this positive. Doesn't really matter. Right? So we want to go with solving this. Well, all we're going to do, just going to move our value over to this side and this side. Right? Collect like terms. So we have x here, x here. Move that x over to this side. We have a constant here, so move this constant over there. 2x minus 3x equals negative 8 minus 3. Or 2x plus 3x equals 8 minus 3. Right, so collect like terms. Once we collect like terms, we go to the next line. That's just going to leave us with, well, 2x minus 3x and negative x equals negative 11, or 5x equals 5. So get rid of the everything attached to the x. That just gives us x is equal to 11, or x is equal to 1. Right. So once again, I drew this one to scale actually this time. So we can imagine that this is just going to be our 3x minus 8 on this side. Right, so we have a greater slope. 2x plus 3, well, that's just going to be, yeah, so 2x plus 3 is going to be on this side. 3x minus 8, that's going to be on this side. Right. So the blue is 3x minus 8. This is 2x plus 3, because we have to account for the shift. And we see that when we draw out their functions, they do intersect at 2 points only, right? And this does make sense. So we have 1 here and 11 here. This one's solve for x, the absolute inequality absolute value 4x minus 3 less than or equal to 2. Write your final answer using intervals. So once again, we're going to have a positive and negative case. So here we can split this up into AND cases. The reason why we can split this up into AND cases is because this is going to be bounded within some region, right? We show that later on, but in any case, so we have plus 4x minus 3 less than or equal to 2 and minus 4x minus 3 less than or equal to 2. So for the next line, we're going to have 4x minus 3 less than or equal to 2 and 4x minus 3 greater than or equal to negative 2, right? I divided by the negative 1 here to get rid of it. Any case where we're dividing by the negative with respect to, or multiplying by a negative, it doesn't really matter. With respect to absolute value sign, or inequality, you need to flip the sign. So make sure to do that. So here's less than or equal to, now it's going to be greater than or equal to. We notice that from our cases of our AND case, we have a is less than or equal to b, and a is greater than or equal to negative b. Right, so in this case, we can actually just say that negative b is less than or equal to a, less than or equal to b. Right, so this is going to be our bound. Moving on from this, we can rewrite it into this form. So we have negative 2 less than or equal to 4x minus 3 less than or equal to 2. If we want to get down to x only, we're going to see where we have 4x minus 3, so we're going to need to add 3 to reverse the operations. Add 3 to all sides. So less than or equal to, less than or equal to, plus 3 plus 3. That gives us 1 less than or equal to 4x less than or equal to 5. We have something still attached to the x here. We have 4, so we need to divide by 4. That's 1 over 4 less than or equal to x less than or equal to 5 over 4. Since it wants us to write this in interval notation, we're going to do that according to square brackets, right? Square brackets means that it is inclusive of that value, right? So you'll notice the difference. Square is less than or and equal to, less than or equal to. And the curly brackets just without, so that would just be less than. Right? So less than or equal to, less than. So from this, we're just going to translate that. The least value is going to go on the left side. The greater value is going to go on the right side. Square bracket, because both inclusive. 1 over 4, comma, 5 over 4. If you want to imagine what this originally looked like why this is a bounded case, you can just immediately jump to the step if you want. Make sure that you visualize it first, because it's not necessarily going to have any value solutions. Right, like if it says like less than or equal to, let's say like negative 2, well, we're going to see that it's always going to be above that, so it's not going to work. Right. Yeah, so drawing out the function here, we see that we have 1 over 4, 5 over 4, the intersection points. So less than or equal to, well, it's just going to be within this bound here. So that's a bounded case. This is a case where it's not bounded. So solve for x, the absolute inequality, absolute value 2x plus 6, greater than or equal to 3. Write your final answer using intervals. So in the case where we're dealing with unbounded, we're going to use the term or, right? Like different possible solutions. It's not going to be between something, it's going to be multiple different ones. So once again, we have positive and negative case, positive 2x plus 6 greater than or equal to 3, or negative 2x plus 6 greater than or equal to 3. Go to the next line, multiply or divide that negative away, switch the sign here, move our constants over, so 2x greater than or equal to negative 3, or 2x less than or equal to negative 9. Get rid of the values attached to our x, and then we have just x greater than or equal to negative 3 over 2, or x less than or equal to negative 9 over 2. So when we're dealing with infinity, when we're talking about intervals, we're always going to use the open bracket, the open curly brace, right? We're not going to say equal to infinity. That doesn't really make much sense. But it's supposing that we're going to infinitely go towards something, we're going to say it's less than whatever that infinity is, right? So always use a curly when you're talking about infinity. Since this is once again inclusive, greater than or equal to, we're going to use square brackets for our solution values here. Square bracket, since this is the, what is it? Yeah, the greater of the two. Negative 3 over 2 is greater than negative 9 over 2. This is going to work out such that in the case that it's not going to be bounded, right? Since this is greater, this is just going to tend towards infinity. So we have negative 3 over 2 less than infinity, and greater than negative infinity less than or equal to negative 9 over 2. If you want to visualize that, We have our y equals 3, absolute value function. We want to see when it's greater than or equal to 3. And we see that beyond this point it is, and less than this point it is. Pop, pop. Okay, so 5. Find the equation of the line which passes through the points with coordinates 0, -1, and 4, 3. Write your answer in standard form and in slope-intercept form. So this one isn't that bad. First thing that we're going to do is find the slope. So what is the slope? Well, the slope is just the rate of change with respect to what? Typically, we're solving, with respect to y. Y equals mx plus b. So in this case, that means that we're going to want to take the slope with respect to y2 minus y1 over x2 minus x1, right? If you want to think about this, this is the difference in the output and the difference in the input. In that case, that is just going to give us the rate of change or the velocity, which is precisely what we want. So in this case, we have, 0, -1, and 4, 3. Summing this in, we have 3 minus -1 over 4 minus 0. Well, that's -1, -1, which is +1, so that gives us 4 over 4, which is going to give us 1. If you want a visual for how you're going to calculate that, I did draw it out over here. Right, so we have our x2, y2, x1, y1. The difference is simply just going to be y2 minus y1 over x2 minus x1. The next piece is you want to find the answer in standard form and in slope-intercept form. So we can do this two ways. We have our slope. Now we can either sub it in with respect to the points here, or we can solve for y equals mx plus b, where we solve for b. I would always do this one. This is simple. This just gives you the points directly. We already have points, so we have the slope. So that means we can just take that y equals m, well that's just 1, bracket x minus some point. I chose to do the first point because that has 0, that's just nice to deal with. So y equals x minus 0 minus 1, because we have -1 for y, which is going to actually directly give us the slope-intercept form of y equals x minus 1. From the slope-intercept form, we can find the standard form, right? We're just going to make sure that we move everything over to the left side that isn't a constant, which gives us x minus y equals 1. Right? So if you want to, you can also do y equals mx plus b and solve for b, but that's just more work, right? You can just sub it directly into this one. That'll be fine. This one is find the equation of the line that is parallel to the line 4x minus 7y equals 2 and passing through the point -1, 2. So in this case, what we can just immediately start to do, since it wants a line that is parallel, we're going to want to find the slope. So we can move everything over except for the y to find the equation of this line, which just gives us y is equal to 4 over 7x minus 2 over 7. Since it is parallel, right, that means we want the same slope. We know the slope is going to be attached to the x. That's going to be with respect to our input, which is going to determine the output rate of change. Right. So that means this is our slope parallel. So that means we have m is equal to 4 over 7 for some line. The next point is we have that we want it's passing through this point. So once again, you can either use this method or this one. I prefer this one just because it gives you everything you need. We quite literally can just sub it in and then immediately get the answer. This is the line. If you do this one, you're going to have to solve for b. That's just annoying. So yeah, we have 4 over 7, bracket 7 our point. Since x minus x1, well, we have x1 is -1. That's x plus 1, and then we have y1, which is just plus 2. So that would work. 7. So this one, solve the linear system. 2x minus 5y equals 8. And 3x plus 9y equals -12. So before you, by using the substitution method, before you start, you should look at which system is nicer to deal with, if you can. I noticed that the second system, it's all multiples of 3. We have 3x, 9y, -12. Those are all divisible by 3. Specifically, we have 3x. Whatever's attached to x is the smallest of them, and it's 3 itself. So that means that what that means is if we solve for x, well, it's just going to be super simple, right? We can just divide all of these by 3, and we're going to be left with no fractions. It's going to be nicer to deal with. If you use the top one and you solve for x, well, then you're going to have you're going to have 5 over 2. That's just not nice to deal with. So yeah, in any case, you're just going to choose one, and you're going to choose one variable to find. I chose the second system, and I chose x. So I found what x was, just move everything over. Now what you're going to want to do is you're going to want to sub that back into the other equation that you didn't use. I solved for x in the second, so I'm going to sub this back into the first. Right. What that's going to give us is that's just going to give us the solution for one variable, and after we find that, we can sub it into either one. So here we go, we have the first one, 2x minus 5y equals 8. We found x for the second one here. Sub that in. That's only going to give us a y and some constant. So just expand this out, collect like terms, simplify, get negative 11y equals 16. Just divide by negative 11, we get y equals negative 16 over 11. Since we have what y is equal to through multiple system substitution, that means we can just sub y into either one to find the answer, right? It's going to be the same. If you can sub it into one where you get rid of the fraction, that's really nice. You won't always necessarily be able to. I subbed it into the first one just because I was going to multiply. Just lower numbers to deal with is generally better. Right? You don't want to multiply by a 3-digit number. So yeah, this is lesser, so I subbed it back into that. 2x minus 5y equals 8. We have 2x minus 5. Sub that in. We have y equal to this. Negative 16 over 11 equals 8. So that's just 2x plus 80 over 11 equals 8. Move this over to this side. 8 minus 80 over 11. Then 2x equals 8 over 11. Just divide by 2. 8 over 2 goes to 4, and then 4 over 11. That's pretty much it for that. So once again, for this one, we also have a very nice thing to deal with. You'll notice that we have multiples of 2 for the second equation. Specifically, we have 2 itself attached to x. So that means if we solve for x, we're going to get no fractions. So doing that, moving everything over, divide by 2, we get x is equal to 2y plus 5. Since we, once again, dealt with the second one, we're going to want to sum that back into the first. So 5x minus 4y equals 8. Sub this value of x into this system. So 5 times 2y plus 5 minus 4y equals 8. This is just expand this, collect like terms once again, divide. We get y is equal to negative 17 over 6. So for this one, you can sub it into either one. I chose the second one just because we had lower multiples with respect to x. Right? I just think that's generally easier to deal with. You'll also notice that potentially once we deal with everything we multiply it out, it's just going to be more easily divisible. Divisible. So 2x minus 4y equals 10. Subbing in our y, that gives us 2x minus 4y minus 4 times negative 17 over 6 equals 10. Just multiplying that out, we get 2x equals 10 minus 34 over 3. Right? We can divide this by 2, the top and bottom. Gives 2x equals negative 4 over 3. Just gives x equals negative 2 over 3. So this one's a bit different. Solve the linear system of those two equations by using the elimination method. So the elimination method is just adding or subtracting some multiple of either both. You can take the multiple of the first and the second, or just one, such that you eliminate one of the variables. So what this looks like here, we'll notice that we have negative 4y and 2y. Well, they're both multiples of 2. Right, so what we can specifically do is we can figure out what multiple we would need to take with this one and this one, such that when we add them, they cancel out. You can also do the x. I chose the y just because, you know, it's 2 and negative 4. Well, I can just multiply this by 2 and then add them to get rid of them. That's what I did. I chose to multiply the second system by 2 because that would give us 4y, and negative 4y plus 4y is just 0. Multiplying by 2 gives us 3x minus 4y equals 7 plus 10x plus 4y equals negative 10. That just gives us 13x equals negative 3, which gives x equals negative 3 over 13. So we can use this and sub it back into either one. Once again, I chose the one with the lower multiples. I don't want to deal with higher numbers. So that's just 3x minus 4y equals 7. Sub in negative 13 over negative 3 over 13 for x. 3 times negative 3 over 13 minus 4y equals 7. Collect like terms once again, divide, blah, 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 blah. We have negative 4y equals 100 over 13. We can divide 100 by 4, that just gives us 25. Keep the bottom, so it's y equals negative 25 over 13. You can also check these if you want, right? Like you can just sub in the values and see if they're both equivalent. Question 6. Like if you want to make sure that it actually passes through that point, well, you can sub in your value. So like here we'd have 4 over 7, negative 1 plus 1 plus 2. And we see that this is just going to go to 2. Right, so this does work. Right, this is x equals negative 1. So you can do that if you want. That's it for that. So 10. Solve the linear system. So here we have 4x minus 3y equals 3. And negative 3x plus 5y equals negative 1. Here we don't have any easy multiples. But what we can do is we can multiply this value by this one, and then what we're going to end up with is a common multiple, right? So 3 times 4 goes to 12, and 4 times 3 goes to 12 as well, right? So you're basically just doing a times b, b times a, essentially, right? So we can do that for both. I chose to do it with x. So that means we have 3 times the first equation, 4x minus 3y equals 3, because we have 3 down here. And then 4 times negative 3x plus 5y equals negative 1, because we have 4 up here. So that's going to make them equivalent, irrespective of their sign, which is what we want, right? We want the negative and positive. So then we have 12x minus 9y equals 9, and negative 12x plus 20y equals negative 4. That's just 11y equals 5, divided by 11y equals 5 over 11. So once again, you can choose to sub this into either one that you want. I chose to sub this into the first one, lower multiples. If you can multiply it by something that cancels out the fraction, do that, I would say. That's very nice. But yeah, so the first one, 4x minus 3y equals 3. So we have 4x minus 3 times 5 over 11 equals 3. Collect like terms, multiply. 4x equals 48 over 11. 48 over 4 is just 12, so that gives us x is equal to 12 over 11. But yeah, I believe that is it for that.